Hi everybody, we'll be getting started soon, about 4 more minutes. Go ahead and fill your water, use the restroom. Have a pencil and notepad handy because we're going to do math today. Hello everybody, hope everyone's doing alright. Welcome back to Chem 121. This is the Tuesday Week 2 lecture, and the good news is that we're 10% of the way through the class at this point, so we made it through the first week. The bad news is today we have to do math, and there's lots and lots and lots and lots of math in Chapter 2, and we're going to do almost all of it today. The good news on top of the bad news is that because this is all online, you can go back to the archive and watch the video as many times as you want. You can ask me any question that you want. We can answer those questions on Wednesday. And it's not going to be like class where I say it once and then after the class is over, like it's gone. It'll always be online for you. So if you get stuck on something, again, make sure you're using the discussion board. Make sure you indicate what problem and also what addition. I would just type out the problem if you get stuck on something. And contact as many people, including me, as possible to help you learn how to do the problem. We're going to do a bunch of extra problems today, hopefully to get something resembling a sort of blueprint underway. There are some questions in the chat. For practice problems, I don't really have a good answer for that unless, like, other students seem to be volunteering. I don't have a copy of the textbook that I can photograph. I think as the instructor, I probably shouldn't be doing that. If you look around online, maybe you could find a PDF of the book that's available. If other students are willing to help, that is perfectly fine. You can make arrangements with each other. Again, use the discussion board for that sort of thing. The worksheet will be due when it is announced to be due. We'll talk about that more tomorrow during the Wednesday lab lecture. I'll talk a little bit more about the Wednesday lab lecture at the end. It's not going to take very long for me to talk about because the first worksheet is very straightforward. It is literally what we're doing today. Just 25 times. So you get a lot of practice. All right, so before we get into the dimensional analysis stuff, which is sections 2.7 and 2.8, let's talk a little bit about scientific notation first. Scientific notation is something that you should be somewhat familiar with. It is a way to write really large or really small numbers. So, for example, if I had this number, the number of cells in an average person, I could write out all these zeros like this, and that would be super tedious because every single time I would have to write all of these zeros here. In order to avoid writing tons and tons and tons of zeros every time we write out a long number, and reduce the chances that we make an error, because I have to write out 13 zeros every time, and if I skip one of them, the number is no longer correct. What we do is we append something like this to the end. This number on the end is a multiplier. Currently, it has a value of 1, because anything raised to the 0 power is equal to 1. So I take my 10 million times 1, and I haven't really done anything. If I can change this number and then move this dot somewhere else so that the value is retained, I could write the number a lot more compactly. If I move this dot over one time, then my number would be 10 times smaller than it currently is. So if my dot was, say, here, now the number is 10 times smaller. If I were to put the number, or the dot, instead, like, say, over here, now it's 1 billion times smaller, and so on and so forth. Then what I would do is I would just change this number to whatever I want it to be to make the number have the same value as before. So let's see that in action, and I hope everybody likes this because it took me 47 minutes to animate this. Ready? Here we go. There you go. Okay, it can stop flashing now. I didn't mean to make it blink that many times. So I move this dot 13 spaces over here. That's like dividing by 10 to the 13. So I'm going to just times by 10 to the 13 to give it the same value. And then here's my answer. Now this number as written has 1 decimal place shown. So this is a little bit misleading. What I should actually say is that this number here has 2 significant figures. If I instead wanted it to have more than 2 significant figures, I would just write more zeros at the end. Because remember, these follow the decimal rule. And if there is a decimal point, you have to use the decimal rule. Alright, you can do the same thing with small numbers. For example, the width of a human hair is about this thick. That is a very small number in meters. If I move the decimal point to the right, that's like timesing my number by 10 to the 5. Oops, I didn't mean to do it. Now you get to watch it again. Haha. There you go. That's like timesing by 10 to the 5. So I need to divide by 10 to the 5, or multiply by 10 to the minus 5, to get the value to be the same. And this is now our number in scientific notation. This number is written as 2 sig figs. Generally speaking, the number of significant figures of your answer in scientific notation should match the number of sig figs as a decimal or regular number. The exception to that would be if I needed to write a number specifically that I can only get the correct number of sig figs by using scientific notation. And here's an example of that. And I guess this person will, or this, she'll just be hanging out right here in the corner staring at you. Oh, I'm not writing on my PowerPoint thing. There we go. Okay. So, if I had this number, there we go. It just took a second to appear. This number, as written, has two significant figures. But let's suppose that I wanted to have instead 4 significant figures. And I wanted to have a number that had this value. Well, I can't just do this, because that's not the same value. It turns out that the only way that I can write this number to have 4 significant figures is to write it in scientific notation. So there's my 4 sig figs. And now I need to put my exponent so that it has the same value. So in some cases, you will be required to write a number in scientific notation just so you get the correct level of precision. Just be mindful of that. All right, and here's our summary. For large numbers, you move the dot to the left. Every time you move the dot to the left, you increase the exponent by 1. For small numbers, you're going to move the dot to the right, and then you decrease the exponent. I didn't get the highlighter here. So big numbers, decimal place moves left, you increase the exponent. For small numbers, you do the opposite. There you go. All right, so just as practice, what I want you to do is I want you to turn these numbers into scientific notation. You're going to want to type answers into the chat to compare, but how do you type something in scientific notation? Here's what you should do. So if I had the number that, 52,000, if I wanted to type that in scientific notation, I would write that something like this, where I have like an X and then a times for my times and then 10, and then that little caret, which is above the 6 on your keyboard, so shift 6. That serves as your exponent. Some calculators use E. I prefer not to use the letter E because E is actually a number in other math classes. It's the logarithm number sort of thing. So try to stick to this notation and you'll be in good shape. Okay? I'll give you a few minutes to turn these in scientific notation, and I'll be back in just a minute. Check up on you. Good luck. We're all counting on you. one more minute to finish up your problems, and then we'll go over the answers. I should probably erase what's on my canvas. Alright, let's go over the answers here. I gotta make sure that these all fit on the screen. We'll just do one at a time here. Alright, so if I wanted to write this number here, what I would do is first I would count the number of zeros that I have to go through in order to, or actually the number of digits, to go through in order to put my number such that I have one number before the decimal point. That means that I would have to move the dot from all the way over to the right over 3, 6, 9, 12 places. And so if I wrote all of these digits in, I would get this as my answer. And then I'll put my units on there because numbers should have units. Otherwise they aren't measurements. Oops, I gotta grab the mouse and do this now. There you go. This number represents the surface area of the oceans. I'm going to write the first digit down. I don't know what my pen just did. There we go, okay. So I want to have one number before my decimal place. If I move my dot over 3, 6, 9, 12, 13, 14 spaces, I will get the same magnitude as the number that is shown up above. And since this is square meters, I would write meters squared like that. And I'm all set. Turns out helium atoms are tiny. Who would have thought? So, in order to write this number, I'm going to move the decimal point to the right, and I want it to have one number before the decimal point and the rest of the numbers after, so that's just that. How many places do I got to move it over? I got to go 3, 6, 9, 10, 11 to get it there. But since I moved to the right, I'm going to put it as a negative. And that'll be in meters. There you go. Those are the answers. Hopefully everybody got those. And again, make sure that you are doing the homework practice as often as you can. It is particularly useful to have done the textbook problems after the lecture that you hear them, but since the lecture is online, you can always go back and review. I would just try and do them kind of close together. If you're just watching the lecture and then not doing any practice, then since you aren't really using it, it's going to go away, and you'll be like, huh? How did I do sig figs? What's a sig fig? And that's not what I want to hear on day 3. Oh, everything we learned on day 2 is worthless. Like, that would be no good. So make sure that you are... Oops. Not bumping ahead on accident. Make sure that you are keeping up on your practice by reviewing the material as we go along. All right. Let's move on to dimensional analysis. This is probably one of the hardest things you're going to do in this class. Good news is after today, it'll be over. The bad news is that for a lot of people, this is the topic that gets them stuck. It's like, oh man, I sort of know how to intuitively do this, but then I get the slightly more complex problems and everything falls apart. And the best advice that I have for you is that to do as much practice work as you can and don't panic. Okay? Panicking is probably the worst thing that you can do. Because if you feel like you can't do it, and then you convince yourself you can't do it, then it's all downhill, right? But take a deep breath if you're intimidated by math, and watch the video over and over and over again, because I'm going to do the same thing multiple times. I'm going to solve all these problems exactly the same way. First, I'm going to do something, then I'm going to do something else, and then I'm going to solve the problem. And if you get that order down and you can follow my pattern in how to do it, you're going to be okay. You're going to be able to do it. Okay? So the first thing we want to do is we want to talk about some of the units that we mentioned earlier, the ones that I told you didn't have to memorize. You still don't have to memorize them, but I'm going to refer to them. First thing we're going to do is we're going to do a little bit of math. So I'm going to have that on the screen there. And I need to find it again, so it's up here somewhere. There it is. So I'm going to take this thing, and what I'm going to do is I'm going to play around with it doing math. So let's do this, and then that, and grab the pen. And here's what we're going to do. We're going to take that statement written above. And the first thing I'm going to do is I'm going to divide both sides by the stuff on the left. So I'm going to just write this and write this. Now in mathematics, when you divide something by itself, what happens? And you should look at that and say, well, something divided by itself equals 1. In fact, anything divided by itself equals 1. It could be 7, it could be 500, it could be the letter Q. It doesn't matter. Whatever it is, if you see something on top of a fraction and on the bottom of a fraction, they cancel, and you're left with something that just equals 1. So what this statement becomes is the number 1, which equals this. And on its own, that's not very impressive, but we're going to put it in a box and come back to it in a second. Now what we're going to do is I'm going to take the same expression, and I'm going to divide by the right side. And now I'll do the same thing. Over here I have 1,000 divided by 1,000, so 1,000 divided by 1,000 is 1. I have a unit divided by itself, which is also 1. So this whole side is just 1, which means that 1 equals this thing. And so we'll box that one too. Finally, what we're going to do is we're going to say the thing on the left equals 1, and the thing on the right equals 1. What must be true about these two things? Well, if they both equal 1, they must equal each other. And so what that means is that I have proven, using algebra, that these relationships are equivalent, and not only that, they equal this relationship that I can't draw to because my screen doesn't go that high. So we can take any vertical relationship that is shown right there. So that 1 kilogram equals 1,000 grams. And we can turn it into, or sorry, I guess that top thing would be a horizontal relationship. We can turn it into these relationships down here. And I can either put the units with the 1 on the bottom, or I can put them on the top. I can do whatever orientation that I want because they are equivalent to each other. Okay? So what we're going to do is you're going to see relationships like this in the textbook. You're going to see all sorts of relationships in tables and stuff, and they're all written horizontally. Sorry, I get horizontal and vertical mixed up for some reason. What your task will be to do is to take those relationships and turn them into statements like this, so that you can use this part of your equation for doing dimensional analysis, which is going to be what we do in a second with these. I gave this the term unity relationship. I don't know if I've ever seen that in any of your textbooks. I saw it in an earlier textbook when I started teaching, and this slide is just stuck around. You don't need to know what a unity relationship necessarily means. But for the people that are curious, it just means that it equals 1. So if you times this circled thing by any quantity, it will still have the same value, but the units will change. And that's actually the intent here, is we're going to turn things from one unit into another unit by canceling stuff out. So the problem is shown on the screen, but what I want to do before we just go on and say, oh, everybody knows how to do this, well, we're going to work on the assumption that not everybody knows how to do this. We're going to devise a plan that helps everybody figure out how to do these problems. And so let's put this on the screen. And we're going to work towards this goal. All right, so here we go. So the first thing that we want to do is, let's suppose that the problem tells you what you should do to solve it. So convert 5 kilograms to grams. And the first thing that you want to do, and I'm going to write this down here too, is you want to devise a plan to link your units. Okay? What this means is that I'm going to take the starting unit and the ending unit, I'm going to write them down. And I'm going to make a little blueprint. And then what I'm going to do is I'm going to try and link them. I can link units that have a relationship between each other. For example, I know that there are 1,000 grams in 1 kilogram. Since I know that relationship exists, I can link these two things together. If I didn't have a relationship that I know the conversion for, I would have to have things link in a stepwise fashion. So this might be my start and this might be my end. And I'll just have to do multiple conversions to get from the start to the finish. Now that I know my link and I know the relationship between the two parts of that link, I can then move on to number 2. Step 2 is to set up the units and cancel them out. And when you do this, it's really important that you deal with the units first before you touch the numbers, okay? The first thing that you want to write down is obviously what you're starting with. So this is actually going to be the only number that you touch for a second here. Then I'm going to make a conversion that uses the linked units to move from one thing to the other. And the way that I do that is I set up the relationship by putting the unit in the correct spot. I have this relationship that connects grams to kilograms. But if I put grams down here and multiply by this, these units don't go away. I would end up getting something like this. None of my units went away, and that's no good. We don't want that. We want the units to go away that we don't need. So instead what we're going to do is we're going to set up whatever unit is up here, I'm going to put it down here. Because something divided by something cancels it out. Now I can put the other linked unit on the top, because this is what I want to turn it into. Each time I have a link, so every time I have a line, I'm going to have one of these conversion boxes. So if I had a second connection to turn it into, say, milligrams, I would have a second one here, and then I'd put grams on the bottom and milligrams on the top. We're going to do that for the next problem, so we'll just stick with this for now. Since this is the unit that I want, that's the unit that sticks around to the end. Now that I've set up all the units, and I know that this is the unit of my answer, which is what the problem is asking for, now I do step 3. And unfortunately, it's not going to fit, so I have to do this, which I'm not a fan of. Wrong color. Sorry. That also looks hideous. When you get to the very end, then you do the numbers. And when I say do the numbers, what I mean is we're going to fill in all these numbers in these blank spaces that we left with the stuff from our relationship. On the link over here, I wrote 1,000 grams equals a kilogram. So I'm going to do that over here. 1,000 grams equals a kilogram. This way I know which orientation to set up the relationship. I put the 1,000 on the top because the units ended up that way. I wanted to cancel this guy out, so I had to put kilograms on the bottom. That left grams on top, and the numbers then fall into place. And now all I have to do is do the math. 5 times 1,000 divided by 1 is 5,000. And so now we have pretty much identical to what we had for the little sample that's up here that's moving around right now because I can't seem to point at it. Okay? That's the simplest problem that we'll do. Remember that you want to do these types of problems always with these 3 steps right here. So devise a plan to link your units, then set up the units to cancel them out using the starting value that is given, and then finally do the numbers. Now, one of the worst things that you can do when you do these problems is to ignore these rules. For some reason, when I teach this process in class, what a lot of students do is they say, oh, well, I sort of kind of know what's going on, so I'm just going to do whatever. And I'm going to just fill in the numbers as I go and not worry about the units and just hit enter on my keyboard, and then I'll just punch it into the internet and it's done. Don't do that. In the internet, I can't really stop you from doing whatever you want to. Oh, step 4 is sig figs, but that's part of doing the numbers. So you're always going to do sig figs with all your numbers when you hit enter. But good catch, that's important, because you want to remember to do sig figs at the end when you resolve your number. As far as this process is going, if you feel like you aren't understanding it, make sure that you stop, come back to this video, watch the 3 steps, and then try your best to do the steps in that order. You don't learn how to ride a bike by watching me ride a bike, right? You don't learn how to be an Olympic athlete by watching somebody do a pole vault or run 100 meters in 10 seconds. Man, that guy made it look easy. I can do that too. And then it turns out to be really hard because learning is hard. A lot of this is really difficult, but the way to get through it and the way to master it is you got to do as many examples as you can. So make sure you're doing it this way, and then eventually it will get to a point where the math will stick and you'll be able to do it because you're just really practiced at it. If you can drive, you don't get really stressed out when you merge onto the highway anymore because you've done it. The same thing will be true of doing these types of problems. All right, so let's go over a few more examples here. So this is the exact same problem that we just did. This bowling ball weighs 6.8 kilograms. How much does it weigh in grams? So let me get this all set up. That's a lot of nothing in my little box here. Oops. I missed the little corner that I was trying to grab there. All right, so what I'm going to do is I'm going to... That's not what I'm going to do. I'm going to cross everything out. No. I don't know what happened there. I want this, so I'm going to cut it. Then I'm going to select everything and delete it. And then we're going to put this up in the corner so that we always have it. All right. So let's go through these steps one at a time so that we can devise this sort of routine. So I need to devise a plan to link my units. So what are my units? I know that my bowling ball is weighed in kilograms. So that must be what I start with. And then I want to know its weight in grams. So that's what I end with. Can I link kilograms to grams directly, or do I need to go through some intermediate unit? And it turns out the answer is we can link them directly because we know that a kilogram is equal to 10 to the 3, or 1,000 grams. So there we go. We've devised a plan to link our units. Now let's set them up with the number we started with. So there's our starting value. And we're going to set up the units so that they cancel. I don't want this kilogram anymore. I want to cancel it. So what unit should go on the bottom? It should be the unit that matches with this one. So I'm going to set it up like that so that these cancel out. Now, what do I have kilogram linked to? Well, over here I have it linked to grams, so that's what will go up here. Since this was the end of the link, and that's the unit that I want, that's the unit that I'm going to keep. So that's step 2. I've set up my units, and they've canceled out, leaving only the unit that I want. And then finally, we'll do the numbers. There are blanks here that I have to fill in. What's the relationship between grams and kilograms? And that's right here. 1 kilogram is 1,000 grams. So 6.8 kilograms times 1,000 grams divided by 1 kilogram after my units cancel out is 6,800 grams. And then as part of our numbers here, since I forget, we should actually be considering sig figs. I mean, I'm already considering them. I'm just not explicitly saying them. We got to look at how many sig figs all of our numbers have. So first off, how many sig figs are in 6.8 kilograms? Well, none of them are zeros, so there must be 2 sig figs. The real catch is going to be this. How many sig figs are in this quantity? And at first glance, you might look at that and say, well, there's only 1, because all of those zeros are placeholders, and there's only 1 digit for 1 kilogram anyway. But remember, these quantities are definitions. And definitions have an infinite number of sig figs. So they do not affect how many sig figs our answer has. As a general rule, when we're working with only metric, the number of sig figs that you start with will oftentimes be the number of sig figs that your end answer has. The exceptions are when there are things like constants in there, which we'll get to later on when we get to like chapter 7 and we talk about the ideal gas law. I'm going to give you a constant. It's a number that will always be there. But if you're just trying to guess, look at the number of sig figs of the first number, and if you only have metric to metric relationships in between, the number of sig figs will be the last one. Alright, so we figured out what the mass of the bowling ball was in grams. Now what we're going to do is we're going to try and figure out its mass in milligrams. And to figure out the bowling ball's mass in milligrams, we need a different relationship. And we're going to do this problem twice. The first way we're going to do it, just taking our answer right here and continuing with it. And I'll even get a new color here. So let's do green. And so what I'm going to do, let me test this. Yeah, that's okay. I'm going to take my number in green. And this is just the number that we just finished with. And I'm going to say, okay, what was step 1 in our plan? Our plan was to devise a plan to link our units. Okay, well, I have grams, but now I want milligrams. Do I know a relationship between grams and milligrams? And the answer is yeah, there's 1,000 milligrams in a gram. Or 10 to the minus 3 grams in a milligram. So that was step 1. I've linked my units. Step 2 is to set up the units and cancel them out. Sorry for scrolling it so quickly. I didn't realize my mouse is that sensitive there. I'm going to set up my units. What unit should go on the bottom? Should be grams. That lets me cancel these out. I'm going to turn grams into milligrams like my blueprint told me. That's the unit I want, which means that I am done with my setup of my units. This is the only unit that's left, so it sticks around. Now we run the numbers. How many grams and how many milligrams? That's the relationship right here. 10 to the minus 3 grams is equal to 1 milligram. And when I punch this into the calculator, I get this number times 1 divided by 10 to the minus 3, and you should get 6.8 times 10 to the positive 6 milligrams. Now, I said earlier we were going to do this problem twice. I actually lied. We're going to do it a third time as well. Because, just in case you were curious, let me get a different color here. That might be too hard to see, actually. Okay, that's better. Let's suppose that you don't like that relationship over there. This 10 to the minus 3 grams, oh, that's weird. But I know that there's 1,000 milligrams in a gram. Well, let's just get rid of this. And instead, what I'm going to do is I'm going to write this relationship that maybe you are more comfortable with. And that's okay if you want to do that. But what ends up happening is that I got to change these numbers to now match my new equation. And now you can see that if I take this number times 1,000, oh look, the answer stayed the same. So either relationship you use is good. However, I would prefer the other one over this one. I personally don't like this one, which is why I'm going to put a grumpy face there. So to answer Heidi's question, I'm going to erase this number, and I'm going to go back to what this was before. And I got to get the same color back. So there we go. So I'm going to put this number in how I have it. And the way that I did this is I have this number divided by 10 to the minus 3. That's the same as me writing this. If I divide by a tiny number, I get a bigger number, right? So this is a number that's much smaller than 1. So 6,800 divided by 0.001 will actually become a really big number. And it turns out to be this number. And that's just kind of how division works. If you divide by a smaller number, the result that you get is a bigger number. All right, so we have one more of these to do. And so what I'm going to do is I'm going to copy and paste this again, because we don't want to lose it. Although I don't like that it keeps putting it down there in the corner. And now what we're going to do is we're going to say, okay, what if I started this problem and all I had was the bowling ball at the start? And I just had this. And I was asked, okay, I want to get my bowling ball into milligrams. Do I have a link to go from kilograms to milligrams? It turns out the answer to that is no. There is no relationship that links these two together. There is no entry on the table that has both of them. If you're in this situation where you don't have a link, then what you have to do is you have to find some sort of intermediary that will link your units together. Is there something I can convert this to and convert this to that would be in the middle. And since we have literally just done this problem twice, that intermediary is this. It's grams. So if I can convert kilograms to grams and then grams to milligrams, I will get the answer. So I know that 1 kilogram is 1,000 grams. And I know that 10 to the minus 3 grams is a milligram. Or 1,000 milligrams to a gram, whichever one. I'm just doing the numbers off the chart. Now when I go set up my units, this will happen. Remember that I still want to get the bowling ball's mass in milligrams, so I'm going to set up kilograms like this. I'm going to put the linked unit above it, which is grams. And when I cancel these out, I'm going to say, hey, that's not the answer that I want. I don't want an answer in grams. I want an answer in milligrams. So I'm going to do another dimensional analysis setup and do the same thing. And I'm just going to keep doing that until I get all the way to the end of the chain. So you can have multiple of these steps, and you just tack them on one after the other. Since this is the unit that's left over, and that's the unit that I want for my answer, now we can do the numbers. What's the relationship between kilogram and gram? Well, we wrote that over here. 1 kilogram, 1,000 grams. What's the relationship between grams and milligrams? We wrote that over here. 10 to the minus 3 grams, 1 milligram. Punch it all in your calculator. 6.8 times 1,000 divided by 10 to the minus 3. And I assure you that you will get the same thing that we got before, provided that you enter it in your calculator correctly. Make sure that you're using abundant parentheses, and you'll be all set. All right, that's how we convert simple dimensional analysis problems using the metric system. So your task is going to be to do these sorts of conversions and get from some unit to some other unit. On the next slide, I have a few of those. Oops, I thought I had homework practice on that. What I want you to do is I want you to convert the unit that I give you to the unit that I'm asking for. So the first problem is liters to centiliters. The second one is kilograms to milligrams. The third one is a different unit. You've never seen the Joule before, but you could treat this thing as if it was a meter or a liter or a second or anything. Because the centi and the killi operate by the exact same principle. They're just prefixes, and you just stick a J at the end. For what it's worth, the joule is a unit of energy or heat. Okay? Think of it like a calorie. If you ate something that had that many centijoules, you would gain that much energy. Okay? So try these 3 problems. Remember, follow the 3-step plan that I wrote out for you. Step 1, Step 2, Step 3. Hopefully you have it written down because I can't call it back up just yet without removing the problems. Okay? I'll give you, we'll say 6 or so minutes to do these. I'll be in the chat helping you out. If you get stuck, make sure you put your answers in there when you do it. Good luck. We're all counting on you. All right, just a few more minutes working on these. I have a timer going during these so that I'm not just, like, stopping you too early. We're going to go over these answers, and then we'll take our 10-minute break. And then we have more of these. This is all we're doing today, by the way. It's just these problems forever and ever. Go ahead and finalize your answers, and we'll go over the answers in just a second. All right, so here's our strategy once again on the board. We want to devise a plan to link our units. Then I want to set up the units to cancel them out, and then I got to do the numbers. With these sorts of things, so remember that these metric prefixes, so centi, milli, micro, kilo, etc., these are all prefixes, right? Which means that they must go before something. And that something is going to be our units like meter, second, liter, mole, or in this case, joule that we're going to see later. So if I attach these units to all of these things, then I would have like a centiliter, or a centisecond, or a hundredth of a second, or a hundredth of a liter, or whatever. Okay? So I can attach the prefixes to any unit that I want. We don't always have to work in grams, for example. We can work in meters. A centimeter is a hundredth of a meter, just like a centigram is a hundredth of a gram. So let's write down the units that we know and the unit that we're trying to get to. So I have an eraser, apparently. Hold on. 2 liters, and I need to get to centiliters. Do I have a relationship between liter and centiliter? And the answer is, of course I do, because I know that centi is 1/100th of something, right? So there must be 10 to the minus 2 liters in a centiliter. Because that centiliter, it could just be meters instead, and it would be the same problem. But it's not, and I can only undo one of those, apparently, so we're working with liters here. So we're going to use liters. So I got to hit the paintbrush again. All right, so I've linked the units. I can now set up my units and cancel them out. So let's start with the value that I was given, which was 2 liters. I'm going to times that by my conversion factor, which will get rid of liters by putting it down here. We'll put the unit that I want to turn that into on the top. That's the target unit. That's the unit I want, so that's going to be the units of my answer, because this is all that remains. So I have now set up the units to cancel them out. Finally, we'll do the numbers. 1 centiliter, 10 to the minus 2 liters. 2 times 1 divided by 10 to the minus 2 is 200. So you should have gotten 200 centiliters as your answer. How did you do? Hopefully there'll be lots of smiley faces in the chat. I don't really know how to scroll this down without just moving that. Oh, I have all this extra stuff in my slide. That's okay. Let's get a new color. And we're talking about orcs, so we might as well do green. Green is the color of orcs, after all. An orc has a mass of 175.3 kilograms. What is his mass in milligrams? So this is the unit I'm starting with. This is the target unit. Apparently I don't have the right font installed because I'm getting a bunch of boxes, so I'm going to assume that that's a good symbol. Do I have a relationship directly from kilogram to milligram? I don't. That relationship is not shown on the table, but everything else is related to this middle unit, grams. And so I can turn this into this by saying 1 kilogram is equal to 1,000 grams, just like before. For this problem, 1 milligram is equal to 10 to the minus 3 grams, just as before. I have set up my units, so now I've set up my link here, so now let's set up my units. This is the mass in kilograms. I need my kilogram to cancel out, so I'm going to put it down here so that it does. What is kilogram linked to? It's linked to grams. But grams isn't what I want for my answer, so I got to do another step. I want grams to cancel, so it goes down here. What is grams linked to? It's linked to milligrams. So let's do that too. Milligrams is what I do want for my answer, so if I keep this around, my answer will be in milligrams. I'm going to just put a line here to separate those two. I now have everything all set up. I can now do the numbers. Here's my relationship. 1 kilogram is 1,000 grams, so we'll put that right there. And then down here, this relationship, 1 milligram is 10 to the minus 3 milligram. 1 milligram is 10 to the minus 3 grams. So 1 milligram, 10 to the minus 3 grams. I put it all in the calculator, and I should get... That's supposed to be an 8. Let's try that again. There we go. That should be the answer you get. All right, we're going to scroll this guy down a little bit more. Apparently that's the edge of my paper. I believe you are mistaken, Photoshop. My paper is as long as I want it to be. Uh-oh. That's not what I meant to do. I made the image bigger. I need the canvas to be bigger. Oh, I gotta do something. Hold on. Layer, background, select all. Paint. Alright, now I have more space to work with. Alright, so number 3. It takes this much energy in centijoules to heat a sample of water to a warmer temperature. How much energy is this in kilojoules? Now, this is a new unit that you've not seen before. Oops, I don't want to write in white. So this is the unit I'm starting with, and this is the unit that I'm ending with. Now, just looking at this, you might think, well, how the heck would I do this problem? I've never seen joules before. Well, you could treat it like any other unit. So if I get rid of this, and I turn it into, like, meters, for example, you could totally solve this. You could turn centimeters into something, and then something into kilometers, and it would probably be meters in the middle, right? With a different unit, you just replace all these instances of meters and put that unit back. So since we were working with joules, we'll just do that. Because the prefixes are universal. You can apply them to anything you want. So if it helps you to just like pick meters because you're familiar with it, turn all the base units to meters and then replace them with the other unit. The other unit being liter, second, mole, whatever. How do I relate centi something with that something? Just like I would have done with the centiliters example above. 1 centijoule must equal 10 to the minus 2 joule, because the table told us. Then for this relationship, how do I relate something with kilo something? Well, in one of these, whenever you have kilo, it's 1,000. So now I have my numbers and my links figured out over here. I can now do the problem. I have this many centijoules. I need to convert. That means this unit's got to go down here. And then I'll put its linked unit above. I didn't actually cancel them. I need to do that. There you go. Joules is not my endpoint, though. I want to get to kilojoules, so I'm going to put joules down here to cancel it. And put its linked unit right here. Cancel, cancel. That is the unit that I want. So let's now do the numbers. How many centijoules and how many joules? Well, this relationship goes here. 10 to the minus 2 and 1. And then this relationship right here is this one right there. 10 to the 3 joules. 10 to the 3 joules. 1 kilojoule. 1 kilojoule. Alright, so now I'm going to punch that into my calculator. And I got this. 4.184 kilojoules. I've been checking for sig figs on these because I've just been doing it internally. But again, because these are all definitions, the number of sig figs that this has will also be the number of sig figs my answer has. Because again, if we're only using metric, that will be true. Alright, when we come back, more of this. I'm going to put the title card up. I don't have the timer up, but I do have break time. Doink. Let me get the timer. And please take a 10-minute break. I will see you once that has elapsed. All right? See you in a bit. Well, I'm just going to sit here and talk without unmuting my stream. My mic is bright red when it's muted, like on my headset, so I should totally know, and I've gotten so used to it that I ignore it now. Alright, so let's do this. And we'll go to the next slide. So let's continue. We're going to do exactly the same thing we just did, but now we're not going to do metric units. We're going to use any units that we want. Sometimes you will have conversions that are available in a different table that you can look up. So this is where the reference to table 2.2 comes in handy. Other times you're going to have to find and research your own dimensional analysis conversions, and I'm going to show you how to do that in just a second. So first of all, let's do this conversion here. So here's that same orc from before. This is a statue that I have on my desk. If it has a mass of 150 kilograms, the statue doesn't have a mass of that. It's if this was like a person-sized thing. Determine this weight in pounds. So how would I go about doing that? I don't know why I hit Alt-Tab. I want to do this. Whoop. Actually, the only thing that we really need in here is this. There we go. Alright, so let me select all. Oh, you know what? We know the three-step plan by now, and I don't know why everything looks so crazy here. Oh, oops, hold on. Part of my worksheet didn't get dyed white. There we go. Okay. Alright, so now what our objective is instead of going from like kilograms to say grams or centigrams or whatever in the metric system, now we need to go to some other unit. But that's not terribly difficult because a lot of people have probably heard already, oh, okay, yeah, I know about kilograms and pounds. I've looked that up before to figure out what my weight is in Canada or something, because they weigh in kilograms or something, whatever. The way you're going to do that is you're going to find the entry in a table in your textbook, and that's table 2.2. For this specific one, here's the relationship that they give. 1 kilogram equals 2.205 pounds. Now, it's important to note that when we are using these definitions, or actually not definitions, these conversions, that whenever you see the number 1 like this, that 1 is exact. But the other number is approximate, and that means that it has a certain number of sig figs associated with it. So this has 4 sig figs as written. You might find a reference in your textbook that maybe says 2.21 pounds. Then it would only have 3 sig figs. Maybe you find one online that says 2.2049 or whatever. Then it has 5 sig figs. That's going to be important because when we get to the end and consider sig figs for our answer, we're going to need to know how many sig figs we've used. Alright, now we can go to step 2, which is set up the units and do all of the dimensional analysis. So I've got 150 kilograms. I don't want to use kilograms, so that's going to go on the bottom. 2.20. Okay, so yeah, if you use 2.20, you would only have 3 sig figs. So I'm going to connect the link unit. I'm going to put that up here. Since that's the unit of my answer, that's the unit that's left over, I am all set. Now I can do the numbers, so I'm going to put in the numbers here. And now I just punch it in my calculator. 150 times 2.205. And what I get is not in the right mode because I had done scientific notation earlier. 330.75 is what I get when I punch it into the calculator. However, now I got to do sig figs. So this number as written and this number as written will affect my accuracy. This one is my exact 1, so we don't have to worry about it. But the number 150 has two significant figures. This number up here, 2.205, has 4. Which one's smaller? So our answer is only allowed to have 2 sig figs. So I got to round my answer to 2 sig figs, which ends up being 330 pounds, and that's what we get to keep. So the mass of this arc should be 330 pounds when you have done the math. So to do that, we did exactly the same 3-step process. So set up your little flowchart to create a link, then put down your units, then do the numbers. If you do it the same way every time, it will become habit. All right, let's do this again with other units. In fact, you get to try these. I'm going to have you do these problems for the next, I'll say 6 or so minutes. The first problem is another mass problem, so do pounds to kilograms. The second one is distance, and then the third one is volume. You may have to look up conversions for some of these if they're not in your textbook, and here's how you do that. So the first thing that I have to do is I have to find the window that I want to share with you. So that's this one. And then I window capture, not video capture, I don't have a video to give you guys. So I want, not that, that's just a timer. I want Wolfram Alpha, that's what I want. So if I do this, and then I do this, I think that's right. Oh, that's what I'm looking at right now. Okay. So this website, Wolfram Alpha, is basically, you can type in any conversion that you want, and it will tell you what that is. So for example, the problem that you're doing requires you to figure out miles to kilometers. So if you do 1 mile to kilometers, it will tell you what the conversion is, and it'll give you a lot of sig figs. This is useful if you just don't have the textbook handy. I realize everyone's at home, and so it's not like your textbook's going to go anywhere. But if like you were at school and you had access to this site on your phone, then you could just type these in. Now, what you can also do, and this is a little bit cheating, is you could just type in any number here, and it will tell you the answer to that. And I could just keep typing in numbers, and it'll change my answer to however I want to. So all of the problems in your textbook that don't have answers in the back, you could probably type them in Wolfram Alpha, and it will give you the answer. So like if a question asked you, what's 5.75 gallons converted to centiliters? And then I hit enter. And it's thinking. It's thinking for an awful long time. Hold on. Wolfram Alpha, are you okay? There we go. There's the answer. I think that was a website thing and not necessarily Wolfram Alpha. That's probably my internet being slow. So using Wolfram Alpha to look up whatever conversions you need and also to check your work, what I want you to do is try and do these problems. Now, you might be asking yourself, well, gee, that makes the exam really easy. All I have to do is just type it in Wolfram Alpha. I have my ways. For example, I don't have to give you units that exist. I could measure volume in blurps and say that like a blurp is 37 milliliters, and then I want you to give me my answer in kiloblurps or something. So there are ways, but for now, during the learning part, I want you to just be able to get the correct answer consistently. Okay, so go ahead and do that. And in about 6 or so minutes, we'll go over the answers. Good luck. How are we doing? I don't see anything in the chat just yet, so if you get some answers, go ahead and post them in the chat so you can compare with other people. It's a good way for me to gauge how far along people are. Alright, a few more minutes. More like 1 more minute or so. So please finish up the problem you're working on. We'll go over the answers. Let me make sure this is all clear. Alright, let's go over this problem. If I can get my cursor on the right screen here. There we go. Alright, so I am given... This is the starting number, so my starting unit is in pounds. And I need to get to kilograms. So in order to do this, I need to look up a relationship between pounds and kilograms. And this is the one I have from Wolfram Alpha. If you use 2.20, 2.21, either one's fine. Because you're going to get an answer that's close enough. And that's really what we care about, is you just got to get close enough. You got to be within like plus or minus 1 or 2 on the last digit. And all of those little minor decimal issues will get rounded into that last digit, and that's okay. Alright, so now we got to set up the units. I don't want pounds, so it's going to go away if I cancel it like this. I'll turn it into the linked unit, which is kilograms. That is the unit that I want. So now I can do the numbers. I'll just take these relationships and put them right here. And then I punch it into my calculator. Wolfram Alpha, by the way, is also a calculator, so if you just punch in a bunch of numbers and tell it, please compute this, it will do that for you. That was the mass that I got, 263. How many sig figs should my answer have? Well, this number right here has 3 sig figs. This number has 4 sig figs. 3 is less than 4. My answer should have 3. So it looks like a lot of people got it right. Good job. All right, let's do the next problem. This is my actual commute if we were working. Currently, my commute is 0 because I don't have to travel. I do have a Harley. I haven't ridden it for like 8 months since I bought my new Jeep Wrangler, which is nice because then I don't get rained on, but I really miss riding on the highway on my motorcycle. We are going to go from this value, so we have 15.5 miles, and we're going to go from miles to, it looks like, kilometers. And the length that we have here is, I think it's 1.609 km equals 1 mile. I should double check that. Let me make sure that that's correct. 1 mile to km. 1.6093. Okay. I don't need that last digit. That's fine. So I have my link. Everything's set up. Let's go over here. I don't want this unit. Let's cancel it out. I'm going to turn that into the linked unit. That is the unit that I want. Now let's do the numbers. 1 mile, 1.609 kilometers. We'll just enter them down how we see them. And I get 24.9395. That many sig figs because this number also has 3 sig figs. All right. And then finally, the third problem, we got to scroll this. Well, let me leave this on the screen while I'm playing with this. All right. So my 2-liter bottle of soda contains some number of gallons. We're going to figure out what that is. All right, so I've got liters, and I want to turn that into gallons. I actually don't know this relationship, so this one I do have to look up in Wolfram Alpha. There's like 4 liters to a gallon, but I never remember exactly how much, so I'm not typing well, so there we go. 1 liter to gallon is 0.2642. So 1 liter equals 0.264. I ran out of space. That's okay, though. Yeah, if they are just slightly different, you're all set. Like, if the answer was 24.9 in the book and you got 25.1, I accept that. That's fine. You have to be pretty close. I give you a pretty wide window. Now, you do have to have the right number of sig figs. So, if you report 24.987654321, that's way too precise with the 15.5 that you started with. So, make sure that you're getting the right number of sig figs for your answer. But as far as the value is concerned, if you get the value close, I'm happy with it. For this problem, I need to cancel out my liters. I'm going to turn that into the linked unit. That's gallons down here. That's the unit that I want at the end. All right, let's run the numbers. So 1 liter is 0.2642. I don't know why I'm punching this in my calculator. I know it's going to be 0.5. Because even though I write out all those numbers here, 5284, this number as written right here has only 1 sig fig. And so this number only gets to have 1 sig fig as well. So I have to write it like this. And there's your answer. Which I believe was what other people got in the chat here, and that's good. Alright, so that's how we do these basic conversions. So we did metric to metric, and we did metric to imperial. Imperial being like any other units that we use in common parlance, like feet and pounds and stuff like that. Alright, now there are more problems that we can do, and in fact we're going to do those in the next few days. On Thursday, I'm going to show you some other problems. But this unit map idea that's on this slide right here is literally what we've been doing. I'm going to talk a little bit about doing some conversion problems. We're also going to talk about this tomorrow because the whole point of the lab worksheet is to do more of these practice problems. But most importantly, I do want you to read over these slides, maybe attempt some of these more difficult problems, because these problems are going to get more complex. And there's one particular problem that I'm going to give you on Thursday. Let me go to this really quickly. Because you're going to have to do problems where you're working with things that exist. So, for example, this is Hazel. And Hazel is adorable. And what you're going to be doing with this problem on the slide here is you're going to be giving her medication. And that medication is based on how much you weigh. Now, if you give her too much medication... I mistimed that. Damn it. Hold on. Let me try that again. If you give her too much medication, she'll die. And you don't want to do that. So, make sure that you are looking at these types of problems that are coming up, because we're going to be putting in all sorts of different conversions here that are going to make very strange and unusual relationships. And it's really, really crucial that we understand the basics before we get to this stuff, okay? So I'm going to scroll back to where we were. Yeah, I totally messed that up. I even had it all set up to just hit play, and then I would stretch the image, and I didn't stretch the image. I caved it in or something. So, yeah, so please don't kill my cat. Anyway, this is where we're going to start next time on Thursday. We're all done for today. We're going to stop a little bit early because I won't have enough time to give you practice if we continue now. But I will be around for the next few minutes. If you would like to ask any last-minute questions about today's lecture, feel free to ask them in the chat. I'm going to put the title card back up. Oops, we're not on a break. We're on done, so I might as well just hide those. Everyone, thanks for coming out tonight. It's great to see you all. Please do a little bit of practice, and make sure you read over the documentation for the lab stuff for tomorrow. Oh yeah, I got to tell you about the lab. So how the lab thing is going to work is that on Canvas currently is a little section that says lab worksheet number 1, and it's going to have a PDF and a Google Sheets document. All you have to do is download the PDF and open it and read it. And the Google Sheets is where you're going to input all of your answers when you're done. And then you're going to upload them to me, following some directions that I have posted already. I'm going to tell you all of that in more detail tomorrow. Kind of that's the whole point of tomorrow is I'm going to show you that in real time, like this is where you get the file, this is what you do to upload, that sort of thing. And then we'll spend the rest of the time doing more problems like this, if you'd like, because the whole assignment for the lab is just a bunch of these convert this to that, or convert A to B, or convert feet to meters, whatever assignments. So, that's pretty much it. There's some links that you can click on in the Canvas page. Please do that before tomorrow. We're going to meet again on Wednesday at 5 p.m. for the lab lecture. Lab lectures are available for 2 hours, but I don't see it taking 2 hours. It'll probably be like 30 minutes of me just talking, and then everybody will be like, oh, okay, that makes sense, and then you'll leave. Okay. So if it's not something you want to stick around for like a 30-minute lecture for, feel free to skip it. If you have questions about the lab or something, that's the time to ask them. Or if you just have general questions you want to ask me. Nobody has posted anything on the discussion forum, as far as I am aware, that I need to address tomorrow. So if you have textbook questions or things that you want me to work through, tonight is a good time to post those or send me an email. All right, I'm going to turn off my mic. Thanks again for watching. Oh, when's the assignment due? I'll announce that tomorrow, because I haven't actually decided yet. Thanks for watching. If you have any other questions, I'll answer them in the chat. See you tomorrow or Thursday. Have a good night.